Okay, let's look at number 27 from the exam. The question says the coordinates of the endpoints of AB are A is -6, -5, and B is 4, 0. Point P is on line AB, line segment AB. Determine and state the coordinates of point P such that AP to PB is a ratio of 2 to 3. All right, so let's go ahead and do this. First thing I'm going to do is graph the points. I think the use of the set of axes would be good to do in this situation. So let's graph these points. So I have negative 1, 2, 3, 4, 5, 6, 5. A is here, and then B is at 1, 2, 3, 4, and then up 0. So that's my B right there. So if you have a straight edge, you should use it. So we're going to, now, that's the first part. So we have a point P, which is on this line somewhere. We don't know where, but wherever it is, it's going to cut this line into a ratio of 2 to 3. All right, that 2 to 3 tells me, or I can be thinking about maybe if I could break this into 5 equal parts, and I'm getting the 5 from the 2 plus 3. If I can break this line into 5 equal parts, and then I can just take 2 of them, and then the other 3, and I'll have a 2 to 3 ratio. So let's see if we can do something like that in this case. All right, so what I'm going to do is take this and say, all right, well, what is the slope of this entire line? Well, I can do that by doing rise over run. So I can do my right triangle right here. All right, remember the slope is equal to rise over run. This slope is going up from the left to the right, so it's a positive slope. Okay, so my slope is 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my slope is 5 over 10. So my rise is 5, my run is 10. And if you reduce that, you actually get a slope of 1 over 2, or 1/2. So what that's saying is I can go up 1 over 2 from point to point. So I'm going to go ahead and do that. So I'm going to go up 1 over 2, up 1 over 2, up 1. Should have my line there. All right, so if I really had drawn this line correctly, it should have gone through, it should have really gone through these points right here, right there, right? And now, this is a nice problem because if you look, we have our 5 parts right here. 1, 2, 3, 4, 5. So now, looking at this, where could I put P to where the ratio of AP to PB would be 2 to 3? Well, if I put it right here, right? So now my AB would be this line, AP, and then my PB would be over here. So the ratio would be 1, so I have 1, 2 parts, A to P, and then P to B is 1, 2, 3. So if I have my P right here, that is going to make my ratio 2 to 3. So that point now, remember, we have to state the coordinates of point P. So the coordinates are 1, 2, 3, I'm sorry, here, -2, and down 3. So we have -2, -3. That is your point in order for your ratio of AP to PV to be 2 to 3. All right, there you go. Okay, let's look at number 28. It says, the diagram below shows a ramp connecting the ground to a loading platform. So the ground to a loading platform. And the loading platform is 4.5 feet above the ground. All right, the ramp measures 11.75 feet from the ground to the top of the loading platform. So that's the top of the loading platform. Determine and state to the nearest degree the angle of elevation formed by the ramp and the ground. Well, in order to get anywhere on this problem, you have to know where the ground is. And obviously, in the context of this problem, that's the ground, right? All right, so let's go ahead and figure this out. We have to find this angle right here. This is going to be our x. We don't know what that is. Now, we have, anytime you're looking for angles, you have to use sine, cosine, or tangent. So keep that in mind. We're not looking for the third side. If we are looking for this length right here, this length right there, we could use a squared plus b squared equals c squared because we have two sides of a right triangle, but we're not looking for that length. We're looking for an angle. And you always have to use sine, cosine, or tangent when you're looking for an angle. All right, so we'll pause this and I'll be right back. Go ahead and try it. Okay, now let's go. I want you to write down what I wrote here. If you are looking for an angle, you need to use sine, cosine, or tangent. Remember, someone could tow us, some old horse, call another horse, taking oats away. All right, let's set this up now. Now, you have, based on the angle you're looking for, you have the opposite side, and you have the hypotenuse. So if you look down here, opposite and hypotenuse is going to be dealing with sine, opposite and hypotenuse. So usually we'd have the sine of some angle equals the opposite of the hypotenuse. But in this case, we don't have the angle. So we have sine of x is equal to 4.5 over 11.75. Now, whenever you're looking for an angle, you need to use the inverse. All right, inverse sine. So we're going to have sine -1 of 4.5 over 11.75 is equal to x. All right, so I'm going to get my calculator now. And I'm going to make sure I'm in the right mode. Remember, hit mode. You want to make sure you're in degree mode, which you are. For you guys taking the geometry test, when you get your calculator, I'm almost positive it will be in radian mode, which means you have to change it to degree mode, and there's no reason for you to have it in radian mode in geometry. So just put it in degree mode and keep it there. All right, so it's in degree mode. We have to hit second, and then sine, and then I'm going to use the fraction, so I'm going to go green button, y equals, enter, and go back here, I don't remember what I have to put in, 4.5 over 11.75, so I have 4.5 over 11.75, hit enter, and my degree is 22, let's see, to the nearest degree. All right, so that to the nearest degree would be 22.5, so that's going to round up to 23 degrees. So my x is approximately 23 degrees. That is your angle of elevation. Okay, this is the last one I'm going to go over for this video. It says in the diagram below of circle O, the area of shaded sector AOC, and that is going to be this sector right here, AOC, is 12 pi inches squared. inches. Let me erase it. And this marker here. All right, so this area. All right. Let's see, the length of OA is 6, and OA represents our radius. So our radius of this circle is equal to 6. We want to know the angle, determine and state angle AOC, which is going to be this angle right here. Now, there are a lot of different ways to do this. Couple things. Remember, a circle is composed, a circle has 360 degrees. Now, I want you to write that down, just make sure you remember that. The area is equal to pi r squared. All right, I'm going to find the area of this entire circle. So the area of this entire circle would be pi times 6 squared. And the area would equal 36 pi inches squared. So that's the area of the entire circle. So including this sector, that's the area of everything. So this entire circle, it's all 36 pi inches squared, square inches. All right, but we want to know the angle. Well, we know that the area of the shaded sector is 12 square inches. So this represents how much of the entire circle? Well, it's going to be 12 pi over 36 pi. So actually, and it's both inches squared and inches squared. So these cancel out to 1, these cancel out to 1, and when you do 12 over 36, you get 1 over 3. So really, this area right here is 1/3 of the entire circle. It's 1/3. Okay, now the fact that it's 1/3 means that this angle, I'm not doing a different color, this angle is 1/3 of the entire circle. Now the entire circle we talked about 360 degrees. So this particular angle right here has got to be 1/3 of 360. All right, so 1/3 times 360 degrees is equal to 120 degrees. So that is our answer right there, 120 degrees. So I'm actually going to write angle, so the measure of angle AOC is equal to 120 degrees. Make your answer obvious so whoever's grading it doesn't have a problem looking for it. Might as well make it easy on it. All right, so that's it. If you have any questions or you think you see a mistake or anything like that, just let me know.